Now the second type of reaction is decomposition reaction. Decomposition reaction. It is breaking up of a substance into simpler compounds, and it may be brought about by the application of heat, light, electricity, etc. The main property, the main specialty of this reaction is single reactant. This is the identification or specialty of this reaction. Here is always single reactant present in this reaction. Means in this reaction there is always single reactant present. Now we can classify it into on the basis of two things. First one is on the basis of type of products, and second one is on the basis of process which is involved in this reaction, or the process by which the decomposition is held. So on the basis of type of product we can classify it in three categories. First one is when compound breaks into compound plus compound, and second one is when compound breaks into compound plus element, and third one is when compound breaks into element plus element. The main thing is that the reactant in this reaction is one, that is one compound here, one compound here, and one compound here. So in this reaction the reactant breaking down in more than one products by mean of electricity, light, etc., heating, etc. And on the basis of process which involved in this reaction we can classify it into three categories. First one is thermal decomposition, and second one is photolytic decomposition or photodecomposition, and third one is electrolysis or electrodecomposition. Now we can study one by one. Firstly we will study the types on the basis of product. First one is when compound break into element plus element. Now we can take some examples. First one is HgO, that is mercuric oxide, in presence of heat break into mercury plus oxygen. Now we can balance it. Here two oxygen present, so we can write 2 in front of HgO, and 2 atom of Hg present here, so we can write 2 in front of Hg. In this reaction compound HgO is a compound because it has two type of atoms break into element, that is mercury, and second one is oxygen, that is also a element. So in this reaction compound breaks into element plus element, so it is a decomposition reaction because the reactant present here is single means single type. uh, don't confuse with two. We don't study about the quantity, we study about the type. Means HgO is a single type. Here this is not a matter 2 atom present, 2 molecule present, 3 molecule present, 4 and so on, but the type of compound present in reactant side is single, that is mercury oxide. So we can say that single compound break into element plus element, so this is a decomposition reaction. Now we can take another example, H2O. We take H2O and flow a electric current, and it breaks into H2 plus O2. Now we can balance it. Oxygen present here 2, so we can write 2 in front of S2, and here 4 hydrogen present, so we can write 2H2. In this reaction, this is compulsory to know that the water is impure, because we know that in pure water we can't flow electricity. So for decomposition of water we should use impure water, means slightly acidic or slightly basic or slightly salty water. And in this reaction, H2 is the compound and H2 is a element, and O2 is also element, because they have single type of atoms. So we can say that one single compound break into element plus element, means more than one element. So reaction is decomposition reaction, and this reaction is performed in presence of electric current. Now we can take another example, that is AgBr, silver bromide. In presence of light, silver bromide break into silver plus bromine, that is Br2. Here 2 atom of bromine present, so we can write in 2 in front of AgBr, and 2 atom of silver present here, so we can write 2 to balance the equation, and the reaction is balanced. Now we can see that here one compound present in reactant side, here two element present in product side. So we can say that compound breaks into element plus element. It is also example of decomposition reaction, but this decomposition is performed in presence of light, and this in presence of electric current, and this in presence of heat. uh, we will study further that this is a thermal decomposition, because this decomposition is held in presence of heat, so the reaction is thermal decomposition. This decomposition is held in presence of electricity, so it is known as electrolysis or electric decomposition. And this decomposition is performed in presence of light, so it is photolysis or photo decomposition. We will study it further, but now we will study about compounds break into element plus element. Now the second criteria in which compound breaks into compound plus element. Now we can take some more example in which compound decompose into compound plus element. So now we can take example of KClO3, potassium chlorate, in presence of heat and catalyst MnO2, manganese dioxide, it convert into KCl plus O2, potassium chloride and oxygen. For balancing equation, we should write 3 in front of O2. Here oxygen present 6, and we can write 2 here. The oxygen is also 6. Potassium 2, so we can write 2 in front of KCl, and Cl also 2, and Cl also 2 here. So the reaction is balanced. Now we can see that KClO3 is a compound because it has 3 type of atoms. First one is potassium, second one is chlorine, and third one is oxygen. KCl is also a compound. It has 2 type of atoms. First one is potassium and second one is chlorine. But oxygen is element because it has only one type of atom, that is oxygen atom. So in this reaction, compound breaks into compound plus element. So this is also a type of decomposition reaction because the reactant present here is single. And this is also example of thermal decomposition because this decomposition is had in presence of heat. Now the third type of decomposition reaction is when compound breaks into compound plus compound. This is another criteria of decomposition reaction. Now we can take some more example related to this point, in which compound breaks into compound plus compound. Ammonium chloride. When we heat ammonium chloride, it convert into NH3 plus HCl. The more important fact is that NH4Cl is a solid, ammonia is a gas, and HCl is also gas. In this reaction, ammonium chloride is a compound, ammonia is a compound, and HCl is also a compound. So in this reaction, compound breaks into compound plus compound. So it is also example of decomposition reaction, and this decomposition is had in presence of heat. So the reaction is also thermal decomposition. The more important fact that ammonium chloride is a solid, but ammonia and HCl is gas on room temperature. So we can say that in this reaction solid directly convert into gas. So it is an example of sublimation, and NH4 sublimes easily due to because it breaks into ammonia and HCl on heating, and both are a gaseous product, so it convert into gas, not in liquid on heating. It convert directly into gas, so this is a process of sublimation. Now we can take another example, that is calcium carbonate. When we heat calcium carbonate, it convert into calcium oxide plus CO2. Calcium carbonate is a compound, calcium oxide is a compound, calcium carbon dioxide is also a compound. So in this reaction, compound breaks into compound plus compound. So this is also example of decomposition reaction, and it is performed in presence of heat. So we can say that the reaction is thermal decomposition. This is a reversible reaction if we perform this reaction in closed vessel. If we perform this reaction in open vessel, this will be irreversible reaction, because the product, that is CO2, is a gas, and it will be expelled out of the container because container is open. So reaction will not be proceed in reverse direction, because CO2 will be expelled and calcium oxide can't convert into calcium carbonate in absence of calcium oxide. Now we will discuss about second type of classification, that on the basis of process which used in decomposition. The types of this reaction is, first one is thermal decomposition. When the decomposition is had in presence of heat, means process which involved in this decomposition is heating, and when the process which involved in decomposition is heating, then the reaction is thermal decomposition. Now we can take some examples. First one is HGO. When we heat HGO, it will convert into Hg plus O2 or decompose into Hg plus O2. In this reaction, compound breaks into element plus element, so reaction is decomposition reaction, but the process is heating, so we can say that the reaction is thermal decomposition. Uh, Now we can take another example of KClO3. When we heat KClO3 in presence of MnO2 catalyst, it convert into KCl plus O2. Now we can balance it. 2 into 3 6 O2, 3 into 2 6 O2, 2 KCl, 2 KCl. Now this is also example of decomposition, because in this reaction compound breaks into compound plus element. Type of Compound in reactant side is single, so we can say that the reaction is decomposition reaction. But this decomposition is had in presence of heating. So this decomposition reaction is known as thermal decomposition reaction. Now the second type of this classification is photo decomposition. We can define photo decomposition when the process which is used in decomposition is light, then the decomposition is known as photo decomposition. Means the source of decomposition is light, then the reaction is known as photo decomposition. Now we can take some example of photo decomposition. Ag, silver bromide, in presence of light, it convert into Ag plus Br2. Balance Br, we write 2, and for balancing of silver here we write 2. In this reaction, silver bromide convert into silver plus bromine, means one compound breaks into element plus element. So this is also example of decomposition reaction. But the process which is involved in this reaction is light, or the source that is involved in this reaction is light. So the decomposition is due to light. So this reaction, this decomposition is known as photo decomposition. This reaction is used in photography. In photography, we used salts of silver, that is silver bromide, silver chloride, etc. And when we incident light on silver bromide, it break into silver plus bromine. Silver bromide has a pale yellow color, and silver has silver or gray color. Means in this reaction pale yellow silver bromide convert into gray color. And we can take another example of silver chloride, that is AgCl. In presence of light, it convert into Ag plus Cl2, and we can balance it by writing 2 in front of AgCl and Ag. AgCl has a white color, it is a white color compound, and Ag is a gray color compound. Both these reactions are used in photography, in which silver salts convert into silver, means silver salts reduce into silver, and the color of silver chloride is white, and in presence of light it convert into gray color due to the decomposition of silver chloride into silver and chlorine. Now we can take third type of this reaction, that is electrolysis. Electro word is related to electricity, and lysis word is related to breakup. Means the breakup of any compound in presence of electricity is known as electrolysis. That is also known as electrodecomposition. Means decomposition in presence of electricity is known as electrolysis. Now we can take some example. Firstly, we can write the process which involved in electrolysis is electricity. Yes, source, electricity means electric current. The source which used in this reaction is electric current. So the process or the decomposition in which electric current is used for decomposition, the reaction is known as electrodecomposition or electrolysis. Now we can take some example. Process or source of decomposition. Now we can take example of water, that is H2. When we pass electric current from water, it convert into H2 plus O2, or it's break into hydrogen and oxygen. In this reaction, one compounds break into element plus element, so this is also type of decomposition reaction, but this decomposition is had in presence of electric current, so the reaction is known as electrodecomposition or electrolysis. Now we can Now we can take another example of electrolysis of NaCl. Now we take liquid NaCl. When we pass electricity or electric current from liquid NaCl or molten NaCl, it breaks into Na plus Cl2. We can balance it by writing 2 in front of NaCl and 2 in front of sodium, and the balanced equation, this is balanced equation. And in this reaction NaCl break into Na plus Cl2. Here Na is solid and Cl2 is gas. So we can say that in this reaction sodium chloride breaks into sodium plus chlorine, and this decomposition is had in presence of electric current. So the reaction is known as electrolysis. And now we can write note here, as we can classify decomposition reaction into three parts. Compounds break into element plus element, and second one is compound breaks into element plus compound, and third one is compound breaks into compound plus. As we know, all of three is known as decomposition reaction, but the first one is, that is compound breaks into element plus element, is known as analysis reaction. So we can say that all analysis reactions are decomposition reaction, but not all decomposition reactions are analysis reaction. Means vice versa is not true. It means analysis is a subset of decomposition reaction, or decomposition reaction is a superset of analysis reactions. Here all analysis reactions are decomposition, but these decomposition reactions are not analysis reaction. Now we can take some example of analysis reaction. First one is water. When we flow electricity or electric current from water, it convert into H2 plus O2, that is hydrogen and oxygen. We can balance it by writing 2 in front of H2 and 2 in front of hydrogen. The reaction is balanced. In this reaction we observe that the water converted into hydrogen and oxygen. Water break into hydrogen and oxygen. This is also a type of decomposition reaction, but in this reaction compounds break into element plus element. So we can say that the reaction is analysis reaction. In this reaction, this is an important fact that the water is impure, because we know in pure water electricity doesn't flow. So we should use impure water, that is slightly acidic or slightly basic or slightly salty water. Now we can take another example of analysis reaction, that is AgBr. When we pass light or incident light on AgBr, it break into Ag plus Br2. AgBr, that is silver bromide. Now we can write 2 in front of AgBr to balance the equation, and 2 in front of Ag to balance the equation. The equation is balanced. Now this is also a type of decomposition reaction, because in this reaction compounds, that is AgBr break into silver and bromine. This reaction is a photo decomposition, because the source which is used for decomposition is light. So this is known as photo decomposition, and this is also example of analysis reaction, because in this reaction compound breaks into element plus element.